Hello everyone, this is your boy Yes, but sometimes now it's been a hot while since I decided to pick up my old laptop and write a shitty ass script about a scientific topic that I really don't understand much about, despite the high levels of self-awareness demonstrated in the last sentence and the absolutely pathetic attempt to create a video that is some sort of sarcasm or comedy. I've taken a huge L just yesterday, and I need to feel good about myself. So just like you sane people, and because I'm just as sane as you are, I will do the most reasonable thing to do. Commit to studying a subject I don't know anything about. Prepare yourself for an absolute cringe fest by a teenager trying to gather himself up and say at least 2 comprehensible sentences, and not make a fool of himself in front of an audience that consists of 2 people. Big deal. I don't think so, and I really don't care about your opinion, as I'm probably talking to myself right now, as human beings tend to have attention spans shorter than the time I sleep at night. Less than 2 minutes of attention is pretty short. If you ask me now that I'm 100% sure nobody is watching, I shall proceed to give myself another brief introduction, to furthermore give myself a reason not to overthink my decision, while simultaneously overthinking a reason to not overthink. A week ago I totally accidentally, not purposely, trekked over an anime that I really didn't like because I'm absolutely not a weeb, and I've totally seen the light of day 7 years ago, just like normal people who have a social life. The anime is called Steins Gate. It's about time travel, and it mentions CERN's Large Hadron Collider, which remind me of my latest near existential crisis. And in one of my journey I stumbled across an article about the Higgs field. At the time I didn't understand shit, and I thought to myself, wouldn't it be funny if I made a video that is my shitty sense of comedy explaining what it is despite being clueless about it? That is $1 million idea. And I stood up for the first time in the past 15 years, and walked out of my parents' basement, walked out of my apartment, and took my total car to the library. After getting kicked out of the library, because I didn't abide to the laws of personal hygiene, I went back home, walked down the stairs leading to the basement, and went to Wikipedia, the best ever source of knowledge ever, and I found out this nice definition. The Higgs field is a field of energy that is thought to exist in every region of the universe. The field is accompanied by a fundamental particle known as the Higgs boson, and because that just isn't enough to know anything about it, I took 30 seconds of going through Google. I found out about things called elementary particles. What are they, you ask? I had no idea too, prior to writing this sentence. At least I know that they have some sort of relationship with Higgs boson shan. 120 seconds later I found out that elementary particles are a huge field of study called particle physics. As we all know, physics is complicated with a lot of maths in it, but that won't stop my psychopathic curiosity to understand things that are way higher than what my mental capacity could handle, so I chose to learn about the infamous Standard Model of particle physics. But before we say anything, we need to understand some key definitions, at least know what they mean. We don't really need to know everything about the topic to engage in an argument with another fellow virgin on Reddit. 1. In quantum statistics, a branch of physics, Fermi-Dirac statistics describe a distribution of particles over energy states and systems consisting of many identical particles that obey the Pauli exclusion principle. If you paid attention at any of your chemistry classes, you would know Pauli exclusion principle. 2. The counterpart to FT statistics is the Bose-Einstein statistics, and quantum statistics, Bose-Einstein. B. Statistics describe one of 2 possible ways in which a collection of non-interacting and distinguishable particles may occupy a set of available distinct energy states at thermodynamic equilibrium, which is when 2 objects are said to have the same temperature. During the process of reaching thermal equilibrium, heat, which is a form of energy, is transferred between the objects of the same temperature. 3. Fermion is a particle that follows Fermi-Dirac statistics and generally has half-odd integer spin. These particles obey the Pauli exclusion principle. 4. Every type of particle is associated with an antiparticle with the same mass, but with opposite physical charges, such as electric charge. For example, the antiparticle of the electron is the anti-electron, which is often referred to as positron. While the electron has a negative electric charge, the positron has a positive electric charge, and is produced naturally in certain types of radioactive decay. The opposite is also true. The antiparticle of the positron is the electron. Now that we went over some fancy-ass definitions, we shall get to the real talk. The standard model of particle physics offers 12 flavors of vanilla ice cream, and their corresponding chocolate flavors. Interesting. You're not laughing at my joke. Fine, then I'm too lazy to rewrite the previous sentence, so take off vanilla ice cream and put elementary fermions. And since you really don't like Baskin-Robbins, you can take off chocolate flavors and put in antiparticles. The 12 fundamental fermions are divided into 3 generations of 4 particles each. Half of the fermions are leptons, 3 of which have an electric charge of -1, called the electron, the muon, and the tau. The other 3 leptons are neutrinos, which are the only elementary fermions with neither electric nor color charge. The remaining 6 particles are quarks. Leptons are virgin particles. Like you, they don't undergo any strong interactions. Heck, even leptons have 2 classes. One of them, the charged lepton, also known as the Chad lepton, could combine with other particles to create various composite particles like atoms. Quarks, on the other hand, are known as gigachads. 2 or more quarks could always combine together to form little baby hadrons. The most stable hadrons, though, are neutrons and protons. The remaining 6 particles are weirdly named quarks, the up quark and down quark. Together they form neutrons, and protons have atomic nuclei. The charm quark, the strange quark. Yes, these are actual names of science things. And finally the top quark and the bottom quark and their antiparticles. Now that we know all that, and have a decent overview regarding this topic, we can definitely prove our virginity to be supreme over any other Reddit user. Last but not least, bosons. After looking at Wikipedia for 10 more seconds, I've come up with the following. Bosons follow Bose-Einstein statistics, the opposite of fermions, which follow the FT statistics, as I've mentioned earlier. There are 3 types of bosons: spin 1, spin 0, spin 2. Our focus is the Higgs boson. The spin 0, the electromagnetic and the weak nuclear force are theorized to unify in one force called the electroweak. The Higgs boson is the spin 0 boson, otherwise known as scalar bosons, massive ones. The infamous Higgs particle has a weighty task. It grants all the other elementary particles their mass. Without it, we would zip around frantically at the speed of light. 2 footloose to form atoms. Each of the elementary particles acquires its unique set of attributes by interacting with invisible entities called fields. Like football fields, these are large stages upon which individuals, be they electrons or running backs, dash this way and that, and occasionally bash together. But unlike football fields, the fields of physics are 3-dimensional and extend infinitely in all directions, except for massless photons and gluons. All elementary particles